So welcome to 4 Keys Private Tuition. In this video we'll talk about qualitative analysis. So there are some common ions that you must be able to test. We'll start with anions, carbonates, sulfates, and allied anions. So for the carbonates, you react with an acid and you form salt, carbon dioxide, and water. So when you add an acid to an unknown solution that you suspect contains carbonate ions, when the carbonates react with the acid, they must form for you salt, carbon dioxide, and water. What you can do is you can confirm whether the gas produced is carbon dioxide by bubbling it through lime water, and it will turn your lime water milky or cloudy. So add HCl, see whether the gas produced is carbon dioxide by using lime water. So this is how we test for carbonates. When you have a milky color with lime water, you know that you add carbonates. So let's move on to sulfates. Sulfates will react with barium to form barium sulfate, which is a white precipitate. So when you see a white precipitate, that's a positive test for sulfates. However, there are other ions that can also react with your barium to form a white precipitate, and these include your carbonates and your sulfite ions. So you must remove these first. You remove them by adding dilute hydrochloric acid. So your dilute HCl will remove carbonates and sulfites, so that when you add your barium, when you get the white precipitate, you know it's coming from sulfates. So we say these carbonates and sulfites will also form a white precipitate with barium, so you need to remove them. That's the first step. In the second step, when you are so sure that I no longer have carbonates or sulfites, you then add your barium chloride, which is a source of barium ions, and your barium should react with the sulfate ions to form a white precipitate of barium sulfate. So when you get a positive test after removing impurities, you know that sulfates were present. Then for the allied ions, we have the same logic. We need to react them with, to begin with, nitric acid, which will remove impurities. It will remove your carbonates and sulfite ions. After that, in the second step, you add silver nitrate. This time you don't add barium chloride, you add silver nitrate. This is because silver will react with halide ions to form precipitates which have different colors. If it reacts with chlorine or chloride ions, you're going to get a white precipitate. When silver reacts with bromide ions, you get a cream precipitate. When it reacts with iodide ions, you get a yellow precipitate. So when you get any of those colors, you know that you have halide ions. So let's look at the common test for gases. We said you should be able to test for carbon dioxide, which turns lime water milky. We'll look at that in detail. Hydrogen burns with a popping sound, so you need a lighted splint. Then oxygen relights a glowing splint, and chlorine will bleach your blue litmus paper. So for carbon dioxide, we need to know the equation, the reaction that takes place. So carbon dioxide will react with calcium hydroxide solution, which is our lime water, to form calcium carbonate, which is the white precipitate, the cloudy color that we see. So you must be familiar with that equation. So that is the equation for the test for carbon dioxide. Then for chlorine, you need to use blue litmus paper, but you need to dampen it first, and then you put it inside the test tube where you suspect you have chlorine gas. So what happens is that your chlorine is acidic. When it reacts with the water on the damp litmus paper, it will that will produce hydrochloric acid, and that may cause your litmus paper to turn red, but later on it will be bleached, so the red color will disappear. Your blue litmus paper, which would have turned red, will be bleached. So chlorine basically bleaches litmus paper. So let's look at other ions here that you are supposed to be able to test. So you can test cations using ammonia or sodium hydroxide. So we have 2 test tubes for each of those tests. In the first test tube we have our sodium hydroxide. In the second test tube, from my left, in the first test tube we have sodium hydroxide, and then ammonia in the second test tube. So with the zinc, what would happen if you add your sodium hydroxide? You get a white precipitate. So you get a white precipitate. Okay. And with if you add ammonia, what would happen? Let's see. If you add ammonia, you also get a white precipitate. So there's a precipitate there that's forming with your zinc. So you get a white precipitate which is soluble in excess ammonia. So the point to note for zinc here is that when you add your sodium hydroxide solution, you get a white precipitate which will be soluble in excess, and when you add your ammonia, you get a white precipitate again which is going to be soluble in excess. All right. So for aluminium, what happens is that, so let's confirm here, what would happen is that you get a white precipitate which is soluble in excess. So that's a white precipitate forming there. It should be soluble in excess. So you get a clear solution when you add more of your sodium hydroxide. And then you also get a white precipitate with ammonia, which is insoluble in excess. So if you add ammonia, you get a precipitate there, white precipitate. But when you add excess of the ammonia, you see the precipitate is still there. So that's an insoluble precipitate. Then if you were to test for lead, let's see. For lead, you get a white precipitate again. So that's a white precipitate forming with your sodium hydroxide. The white precipitate here is soluble in excess. The white precipitate is soluble in excess. So you must see your precipitate dissolving. And then with ammonia, you get a white precipitate which is insoluble in excess. So that's a white precipitate. And if you add more of the ammonia, you see that the precipitate still remains, so it's insoluble. Okay, then for the calcium, let's see if you're supposed to be able to test for calcium. Yes, sodium hydroxide is going to form a white precipitate. So that's a white precipitate forming there. Okay, and then there's no precipitate with ammonia. When you add ammonia, you get no precipitate. Let's look at the transition elements. So this data you're given, this is why I'm confirming. You'll be given this information when you're doing qualitative analysis tests. You'll be given tables. So no need to memorize all these color changes. You'll be given the information, but you need to have a general picture. So for the transition elements there, our ion 2. So for the ion 2, you get a green precipitate with sodium hydroxide, a green precipitate which is insoluble in excess, and you also get a green precipitate which is insoluble in excess for the ammonia. So you get insoluble precipitates there. Then if you test for the ion 3+, you get a red-brown precipitate with sodium hydroxide which is insoluble, and you also get a red-brown precipitate with ammonia which is also insoluble in excess. So as you can see there. Then for the copper, you have your copper 2+, you get a blue precipitate with sodium hydroxide which is insoluble in excess, and then you get a pale blue precipitate to begin with ammonia which is soluble in excess, giving a dark blue solution. So you can see the dark blue solution there on your copper 2+ after adding excess ammonia. And then for the ammonia, ammonium ions there, you get no precipitate with sodium hydroxide and ammonia. Instead, what you have to do is you have to test by, you heat the solution after adding sodium hydroxide, and you're going to produce ammonia gas. So the ammonia is basic, and it should turn your red litmus paper blue. So this is how you test for the presence of ammonium ions. So hopefully this is very helpful for you. But like I said, you'll be given some of this information, you'll be given tables in your examination, but you must have a general picture. Then it's also important to take note here that the green precipitate that we form with ion 2 turns brown on standing in open air. So you might start to see the color changing, which may become confusing, but you should remember that it will turn brown if you leave it in open air. So I'll meet you in another video.